Section 3.1 and 3.2, I have these combined. So we're going to do lines and angles, properties of parallel lines. Okay, so as you know, parallel lines are lines that are in the same plane that do not intersect. And I have to say that they're in the same plane because there's also something called skew lines, which we talked about. And skew lines are lines that do not lie in the same plane and they do not intersect. And then parallel planes are planes that do not intersect. So most of this we've kind of seen before. So number one, so it says find examples of parallel lines, skew lines, and parallel planes in the picture below. Label the figure with letters A through H. So parallel lines. So who can tell me a pair of parallel lines? So line AB, and EF. That's perfect. Okay. See any other pairs of parallel lines? How about like HD would be parallel with? Yeah, CG. Now, HD could also be parallel with lots of things. It could be parallel with this one, this one, this one. These are all parallel to HD. Does that make sense? Because they can be in different planes, like this one's in this plane here. All right, so there's lots of answers that you guys could get. All right, so skew lines. So how about an example of skew lines? So I'll start you out. So let's say I want GH to be my first one. What's something that's skew with GH? So it doesn't intersect it, but it's not in the same plane. AB, close, but that would actually be parallel. So AB would be parallel because you could actually draw a plane right here. So kind of tricky. AE, yeah, so you kind of need it to be oriented in another direction. So imagine you have like a north-south line, you need something that's like east-west, but not on the same level. All right, so AE would work. So what if I give you another one? So what if I said DH? What would be something that would be skew with that? AE would not. AB would be, yeah. Good. I didn't hear you right. Perfect. All right, and then parallel planes. So planes that do not intersect. So that's going to be like the top and the bottom, or the right and the left, front and back. Okay, and if we're going to name a plane, a lot of times we use, like I talked about, an uppercase letter that's in the corner. But sometimes we don't have that. So if we don't have it, we need at least 3 points in order to name a plane. So we use 3 points. So parallel planes would be something like ABE and GCD. Those would be parallel planes. Do you guys see what I'm talking about? So ABE would be here. CGD would be there. Or GCD. Doesn't matter which 3, like what order you write them in and which 3 you use. Okay, makes sense? All right, so the parallel postulate says given any straight line and a point that's not on the line, how many parallel lines do you think will go through that point and will be parallel to the original line? How many parallel lines can I draw? Just one, right? Does that make sense? I can only draw in one line that's going to be parallel to that original line. And if you think about it, let's say you try to draw other lines. Like if you try to draw other lines in, that one's not parallel, right? It also doesn't go through the point because I'm not calibrated right now, but there's only one line that's going to go through here that's going to be parallel. So we mark parallel by doing like little arrows on it. It's going to be parallel to the original line. And then the same thing with the perpendicular postulate. So if we have a line and a point off the line, there's only one line that's going to be perpendicular through that point, perpendicular to the other line. Does that make sense? Kind of, you guys can kind of see that, right? All right, so let's do a little construction review. So do you guys have your compasses and protractors? Well, compasses and straight edges. You can grab one up here. All right, so it says use the following steps to construct a line that passes through a given point P and is perpendicular to line M. So it says place the compass point at P and draw an arc that intersects line M twice. Okay, so you're going to put your pointy part here, and you're going to draw a swoop below. Okay. Should have put together my new fancy compass. All right, so you're putting the pointy part on P, and then you're doing a swoop with your compass. So mine's not going to be very exact because I don't have a compass I can use with this machine, but it's something like that. Okay. So when you do, you're going to get 2 points of intersection. And you can label these if you want. It says label these as A and B. You don't have to. All right, so now we're going to draw an arc below the line with a compass point on A. So now we're going to do that perpendicular. Do you guys remember when we did the perpendicular, we did this before. It's where we have 2 endpoints and we do like a swoop here and a swoop down here, and then we go to this other one and we do a swoop here and we do a swoop here. That's what we're going to do. So when we do, we're going to get a perpendicular line. So we're going to take our compass and we're going to open it up a certain amount and just kind of make it go past P. And we're going to do it down here as well. So we're going to do it past P. So we had our compass point on A, and we do our swoop here and a swoop here. Now we put our compass point on B, and we do the same thing. We do a swoop here and a swoop here. So if you do it correctly, oops, mine was off a little bit. It should go through point P when you draw your line. Didn't leave you much room below the line, did I? You need to give more space for your construction, didn't I? All right, do you guys have it? So we'll review that in a little bit too. All right, so let's talk about parallel lines. So we're going to first talk about something called a transversal. So a transversal is a line that goes through 2 or more other lines. So a line that intersects 2 coplanar lines at 2 distinct points. Okay, it could be actually be 2, 3, 4. We could have more than 2 lines as well. So a transversal is going to be this line right here, because it goes through 2 or more lines. Okay, so what's going to happen is we're going to have, eventually we're going to have a transversal intersecting parallel lines. And we're going to name these different angles. So we can name the angles even if the lines aren't parallel. So it's a little bit weird when they're not parallel because all the things we're going to do in geometry happen when they're parallel. But let's go ahead and write 1, 2, 3, 4. So see how I went around kind of clockwise? And let's do 5, 6, 7, and 8. And let's name these lines, or these angles. Okay, so corresponding angles. All of these names make sense, you just have to think about it a little bit. So corresponding means that they're in the same location, just on different parallel lines, usually parallel lines. These aren't parallel this time. So what is in the same position as number 2, just on this other line? Yeah, number 6. Do you guys see that? Like 2 and 6 would be corresponding. So what about 1? Yeah, so angle 1 and angle 5, yep. Angle 2 and angle 6. Move my thing a little bit. Angle 3. And angle 4 and 8. Perfect. So don't just memorize the numbers. Know what it means, because sometimes I don't put the numbers in that order. Like I don't put the 1 where I put the 1, right? So it's kind of tricky. All right, so alternate exterior. So alternate means opposite. So we're going to be on opposite sides of the transversal. So the transversal, again, was this line right here. So we're going to be opposite sides of that line. And exterior means we're going to be on the outside of the parallel. Well, these aren't parallel, but of the other 2 lines, okay? So what ones are on opposite sides and on the outside of the 2 lines? Yeah, so 2 and, what'd you say? Oh man, I forgot that I drawn those in. Nice. 2 and 5, almost. So 2 is on the exterior of the 2 lines, but 5 isn't. So 2 and 8, perfect. What else? 7 and 1, perfect. Okay, so now let's do the same thing, but let's do alternate, meaning opposite sides of the transversal, and interior, so inside the other 2 lines. So which ones are alternate interior? Angle 6 and 4, right? So angle 6 and 4. And angle 3 and 5. Perfect. All right, and the last one is same side interior angles, or you might see them called consecutive interior angles. So I think when I was in school, they were always called same side interior, but now textbooks are tending to call them consecutive interior. Really, consecutive kind of leads into parallelograms, which we're going to talk about in a little while. Okay, so what's going to be on the same side and inside of the parallel lines? Angle 4 and what else is on the inside and on the same side as angle 4? 5. And angle 3 and 6. Okay. So what we're going to get to is having parallel lines cut by transversal. So if you have room, kind of draw this little sketch somewhere. So the ones with the parallel lines. So let's draw it kind of tiny next to this other one. Okay, and again, we can label our 1, 2, 3, 4, 5, 6, 7, and 8 there. And I want you to think about things. So let's think about which ones are acute and which ones are obtuse. Okay, so tell me the angles in my drawing down here in the bottom corner. Tell me the angles that are acute and the ones that are obtuse. So let's start out with the acute ones. What angles are acute, smaller than 90 degrees? Angle 2, 6 works, 8, and 4. Okay, notice how I drew those all with the same marking. Those are actually all going to be congruent if we have parallel lines. Okay, and it should kind of make sense if I had, so don't draw this, but let's say I had one that was not parallel. These angles won't be the same, right? But if we kind of move one of these angles, so if I had one like that, and I move this other side so that it is parallel, those are going to be the same. So imagine I have my arms using these as lines, right? If one's like way off like that, they're not going to be the same angle. Okay. Do you guys understand what I'm saying? All right, and then what are the obtuse angles? So 1 and 3, 5 and 7. Okay, so let's go through our list. So this is leading to that next box that you guys have in your notes. So corresponding angles. So let's look at which ones are corresponding. So like 2 and 6 we have. So 2 and 6, do those have the same markings or different markings? The same, right? And 1 and 5, they have the same markings. And 4 and 8, they have the same markings. And then 3 and 7, they have the same. So corresponding angles, do we think that they're congruent or do we think that they add up to be 180? They're congruent, right? How about alternate exterior angles? So 2 and 8. On my little drawing down there, 2 and 8. So those are going to be congruent. So I guess I should say if these lines are parallel. And same thing for alternate interior, those are congruent if the lines are parallel. And then the last one, you would hope that they would be congruent. All of them would just be congruent. Same side interior, so let's look at angle 4 and angle 5. Do they have the same markings? No, these are the ones that are supplementary. So supplementary if parallel, okay? So almost everything is congruent. And really the way that I remembered it when I was in geometry is I would just look to see if they were acute or obtuse. So I'd be like, okay, all the obtuse ones are going to be the same. All of the acute ones are going to be the same. And then if I had, you know, something like 60, or not 60 degrees, let's say 160 here, this other one would have to be 20 degrees because it's a linear pair, right? So then they would add up to be 180. All right, so that's what the corresponding angles theorem is, the alternate interior angle theorem is, consecutive interior, and so on. So it says if two parallel lines are cut by a transversal, then corresponding angles are congruent. So corresponding angles would be things like these two angles, right? Okay, but there's 4 pairs of those. So I'm just drawing in one pair right now. Okay, alternate interior angles. So if parallel lines are cut by a transversal, then alternate interior angles are congruent. So like these two would be congruent to each other. How many pairs of those are there? How many more sets? One more. Yeah, does that make sense? Because they're inside and they're opposite sides of the transversal. Consecutive interior angles, so same side interior angles. Those ones are not the same. That's where they are supplementary. Those are the only ones that are going to be supplementary. And then alternate exterior angles. So alternate exterior angles are on the outside of the parallel lines, and they're on the opposite sides of the transversal. Those ones are also congruent. Okay, does this kind of make sense? Okay. It's not too bad of a section. Just note keeping all these names straight. It's kind of hard. So it says if you're given that lines P and Q are parallel, explain why the measure of angle 3 plus measure of angle 8 equals 180. So this is kind of like a paragraph proof. So when it says explain why, but we don't have our statements and reasons set up, we just kind of explain everything that we need, okay? So 3 and 8. Those are not anything. Those aren't alternate interior or alternate exterior. They're nothing, okay? So what could we use? So let's think about, well, these aren't the same. These are opposite each other, actually. So I want to explain that they add up to be 180. Yeah, so what do you think, Roman? You could say they're obtuse and acute. Yeah, you could, I guess. But let's try to use it. Let's try to make it a little bit more specific, because that's just a trick that I told you. So maybe we shouldn't use tricks that Mrs. Cox just comes up with. Okay, so let's start out with maybe, I mean, you could really use anything. Let's start out with 3 and 4. How are 3 and 4 related? So measure of angle 3 added to measure of angle 4 is equal to 180. What's the name for those? Not anything we learned today, but we've known it. They're what? They are supplementary. But what is it called when we have this line? Line is in the word, yeah. They're a linear pair because they are a linear pair. So we know those two add up to be 180. Now let's try to figure out how we can replace this measure of angle 4 with measure of angle 8. So is measure of angle 4 equal to measure of angle 8? Why? So let's look at it. 4 and 8. They are congruent. What's the name for it? They are corresponding angles, right? All right, so that means that we're going to take this measure of angle 8 and we're going to replace measure of angle 4 with it. So what's that called when I write my new equation? Measure of angle 3 plus measure of angle 8 equals 180 by, what do I call it when I replace something? I heard someone mutter it. Substitution, yes. Property of equality. Perfect. Okay, and that's all we would need to write. Okay, so in many ways, paragraph proofs are easier than statements and reasons, but a lot of my students don't like the paragraph. They'd rather just kind of fill in the spots with statements and reasons. Okay, so it says use the property of parallel lines to find the value of x. What is the measure of angle 1? So we have these markings on this line, these two little arrows. That means that these lines are parallel. Okay, so we definitely have parallel lines. So how do we think x minus 8 and 72 are related? Do we think they're the same or do we think they're supplementary? Okay, so start drawing in your markings. So we have these two have to be equal to each other, the two that I just drew in here by vertical angles, right? Let's jump down to the other line by using corresponding angles. So what's corresponding to the x minus 8? This angle 1, that's right there. So that's not saying that that angle measure is 1. Notice that's not like 1 degrees or anything. It's just a way that we name angles sometimes. All right, and then this one is congruent as well. So they're actually equal to each other. So we're going to say that x minus 8 is equal to 72. So x equals 80. I didn't even need to do this, did I? What's angle 1 have to be? Measure of angle 1 equals 72. How could I have gotten there without doing what I did? These are called vertical angles, right? Does that make sense? So I could have just used vertical angles. I didn't have to make it that hard. I should put my angle 1 somewhere else. All right, so number 3. So it says find the values of x and y in the diagram on the right. Okay, so again, we have parallel lines because we have these little markings here. Okay, and we never want to create an equation that has both x and y if we can avoid it. Okay, why do I not want to create an equation with both x and y? Like, how do you solve it, right? Yeah. We're not going to, how do we solve that? Unless we have a second equation that has x and y, right? So we're going to try to avoid getting an equation with both variables. So I don't want to say that this and this are equal to each other. So what's an equation I could use that would solve for either x or y? Yep, x plus 109 equals 180. Perfect. So then x is equal to 81. So then once you get that, plug x back in. So we have 81 degrees for the blue markings. Now we can set up a second equation. Did I mess it up? Is it 81? No, it's not 81, 71. I saw your confused face, like what? All right, so 71. All right, so we want to set our 71 degrees equal to y plus 7. So subtract it over. What do we get for y? 64. Perfect. Okay, so we have our x and our y. Okay, so they could be more complicated than that, but that's a pretty basic example with both x and y. Okay, still feeling pretty good about this? All right, so it says use the picture on the right and the given measurements to solve for x if lines P and Q are parallel. Okay, so a little bit more complicated. So part A, so it says measure of angle 3 is equal to x squared plus 112. And measure of angle 8 is equal to 16x plus 131. Okay, so we're going to go through it with our markings. So we have angle 3 here. It's the same as angle 1 by vertical angles. We jump down to angle 7 with corresponding angles and 5, right? So 1, 3, 5, and 7 are all the same. All right, so that means that 8 and all the other ones, so 6, 4, and 2 are the same. So when I set up my equation, I'm going to have x squared plus 112. Am I going to say that it's equal to 16x plus 131? Yeah, I can't say that they're equal. So I'm going to say plus 16x plus 131 equals 180. You thought you were going to avoid factoring in geometry, didn't you? This has factoring. Do you guys all remember factoring? Might have to do a little quick review of factoring. All right, so we're going to get everything on one side. So I'm going to have x squared plus, let's see, so what do I have when I do 112 plus 131? So 243. So I'm going to have plus 16x plus 243 equals 180. And then I'm going to subtract that 180 over. So when I do, I get 63. So I have x squared plus 16x plus 63 equals 180. Is this making you guys nervous? Is your heart racing? Oh my God, we have to factor. Can we do this? Yeah, I subtracted the 180. Oh, so equals 0. Yeah, thank you. So what do I get when I factor this? Good. So we have x and x, because they need to multiply to be x squared. Our last terms need to multiply to be 63. So for 63, there's lots of factors. You could have like 3 and 21, right? You could have 7 and 9. You could have, I think that's it actually, 1 and 63. Okay. So if you check and you put 7 and 9 here, I always tell students to look at the outer and inner swoops. We want the outer and inner swoops to combine to be 16x. Do they? We have 9x and we have 7x. Can they combine to be 16? Sure, if they're both plus, they will make 16. Looks like that. So this is all equal to 0. So we get x equals negative 7 and we get x equals negative 9. Okay, so really quickly, we're going to see if both those work. So we're going to go back into the original, and we just want to see if when I plug in that negative 7 7 or negative 9, I want to make sure that I don't get a negative number because I can't have negative angles, right? So if I plug them into the x squared plus 112, I'm good. Do you guys see how x squared plus 112? Doesn't matter what you had, negative or positive. When you square something, it's going to be positive. So let's plug into the 16x plus 131. So I'm going to have 16 times negative 7 and then add it to 131. So that would be okay. This would create 19 right here. And you can check the negative 7 in the other one. So if I try negative 7 over here, you know what, I'm thinking this isn't going to work actually. Negative 7. If I square it, I get 49 plus 112. It's not going to work. All right, so let's try the negative 9. So if I try negative 9, I think I have the same issue. Did I create a bad problem? I wanted you to try to factor, but I think I made a bad one. Yeah, because that's going to be a negative answer. So this doesn't work for either one, actually. So this is a no solution. That was mean of me. I meant for it to work. So did you guys see what I'm saying? When I plug negative 7 in, I would get 16 times negative 7 plus 131. This ends up being 19 degrees. But when I plug negative 7 in up here, that's not going to be 19 degrees. Does that make sense? It's going to be bigger than 112 because of the x squared part. So it's a little bit tricky. Sorry, I won't trick you like that. All right, so measure of angle 3 equals, so maybe this one will work. So measure of angle 3 equals x squared minus 2x. Is there more? So it's like right there. And then measure angle 6, so that's right here. Again, they're going to add up to be 180. So plus 3x plus 108 equals 180. This 5b's over here on this end too. I don't know why it's got cut off. All right, so same idea. So I'm going to have x squared plus x, and then I subtract that 180 over. So when I do, I get what, 72? Negative 72? Like that. I think this one will work. Okay, so we're going to factor. So we're going to have x and x to make that x squared. Our last terms need to multiply to be negative 72. So let's do our 9 and our 8, and then we're going to look at our outer and inner swoops. So we have 9x and we have 8x. We need them to combine to be positive 1x. So that can happen if I have positive 9 and negative 8. So I'm going to put a plus here and a minus there. All right, so I'm going to have x equals negative 9, and I'm going to have x equals 8 when I set each one equal to 0. You guys know what I'm doing there? When I set x plus 9 equal to 0 and x minus 8 equals to 0. You guys have all done this in algebra 1, right? All right, and then we go back and we check. So if I plug in negative 9 into the x squared minus 2x, oh, you know what? That last one might have worked. I don't know. Let me think about it. 9 squared minus 2 times negative 9. So when I plug in negative 9, I get that this one is equal to 99. And when I plug in negative 9, I get 3 times negative 9 plus 108. This one's equal to 81. So do those add up to be 180? Yeah. Were both of them positive angles? Yeah. So we're good with negative 9. Negative 9 works. Now let's try the 8. So I plug in 8, I get 8 squared minus 2 times 8. So I'm going to get 48 for this one. And then I'm going to have 3 times 8 plus 108. So I get 132 for that one. So are those supplementary as well? So this also works. Both answers work. I think this last one, this one did work actually. I was thinking that they were going to be equal to each other. They're not equal. They add up to be 180, right? So let's plug in negative 7 in part A. So if I plug in negative 7, I have negative 7 squared plus 112. Do you guys all have your calculators out? We get measure of angle 3 is 161. And if I try the next one, so if I do 16 times negative 7 plus 131, I get 19. So those do work there. But negative 9, let's try that. Negative 9 squared plus 112. That's already 193 degrees, and then the other one ends up being negative. So you get a negative angle for that one, for one of them. Okay, like negative 13 degrees or something. Okay, so these can be tricky. All right, so the next one, so 2 and, let's see, so measure of angle 2, 5, and 4. So what do we need? So it looks like 2 and 4 are the same angle. They're both acute, right? Those are going to be vertical angles. So we're going to say, okay, well, 8b plus a has to equal 3a plus 5b. That's one equation we could use. Now we only need one more equation in order to solve. So if we have two variables, a and b, we need two equations in order to solve it. So let's look at angle 5. How's that related to 2 and 4? So are they the same angle? Are they supplementary? What do I want to do with angle 5? Okay, look at them, guys. So we have 2 and 4. Does 5 have the same marking, or is it different? It's different, right? So we're going to say angle 5, which was 7a plus 25b, has to add with one of these other ones. Doesn't matter which one. So let's do 8b plus a to equal 180. So when we do that, we have two equations that have a and b. So the easiest thing to do would be to solve this first equation for like a or b, or to get them to line up with a's and b's so we can do our substitution or elimination. It doesn't matter what we do. Okay, so let's look. So we would have 3b minus 2a equals 0 if I get the a's and b's on one side. So I'm going to write it as negative 2a plus 3b equals 0. Do you guys see how I did that? So I subtracted this one over and I subtracted this one over. So let's line up the a's and b's on this other one. So I'm going to have how many a's? So 7a and 1a make 8a. And then I'm going to have 33b equals 180. So we line these two equations up. So it's all coming back to you? Yeah, elimination, right? So how do I want to adjust? What do I want to multiply maybe the top one by? You could do a couple different things. Yeah, you could do either 4 or you could do like negative 11. So I'm going to do 4. I keep it as small as possible. So I have negative 8a plus 12b equals 0. And I have 8a plus 33b equals 180. So doing that allows me to add straight down. So the a's go away. The b's become 45b equals 180. So b is 4. Once we have that, we go back to any equation. So I could go back to like negative 2a plus 3b equals 0. I could go back to that one. I can plug in b equals 4 to get this answer. So I think a ends up being 6. So those are our 2. And then again, you can check those and make sure it works, but I believe that does work. Okay, is this all making sense? And the last one is a big story problem. So this is about Aristophanes. So he was a Greek mathematician, poet, and astronomer. And he's actually the first person to estimate the circumference of the Earth. So he did it using parallel lines. And it basically had to do with, you guys know how like our noon is different than other cities like Dallas, Texas. Their noon is different. Okay, well, they were all basing it on the sun. And he noticed that they couldn't possibly be at the same time of day. Like not the same, you know, like I was saying, we have different time zones, right? We didn't used to have different time zones. So he was saying, well, why does it drop, you know, why is the sun perfectly above at this time here, but if I, you know, was in this other town, it's not going to be perfectly at the same time. So he used that, but we won't go over this problem. So it's kind of a cool problem, but